Processing 6 images with 25 objects for classification went from 1 minute 10 seconds to just 25 seconds with 3 key changes. By the end of this video, you'll be able to discover where your bottlenecks are hiding in your pipeline. Hi, I'm Chan, developer advocate at Daft. I have a collection of images from dog parks around San Francisco. Now I have this Daft script for object detection that identifies dogs and classifies their breeds. I'm going to run this script and show you what the progress bar looks like. In total, this query took 1 minute 10 seconds to complete, but we have very little insight into why it took longer than expected. I'm trying to identify the bottleneck, and it just looks like all the time was spent in the UDF step, which is not very helpful. I'm trying to understand which parts were slow. So in today's video, I'm going to give you 3 tips to help you get more insights out of your progress bar and make it easier for you to iterate on your Daft query. Tip 1. Break your UDF into smaller chunks. By breaking your UDF into smaller pieces, it's easier to see how long each part takes. Instead of one large UDF to read images, detect objects, and then label, we can break each of these steps into their own UDFs, allowing for better concurrency and resource management. Tip 2. Use native Daft expressions. Now that we have a UDF to read images, we should actually use Daft's native expressions to do the same thing. Because we implemented our expressions in Rust, it is much faster and more performant. So instead of using Pillow, a Python library to read images, use Daft's native URL download and image decode expressions to leverage our record-setting I/O performance. By the way, check out our documentation at docs.daft.ai for more on Daft expressions. Tip 3. Tune your UDFs. There's 2 ways you can tune your UDFs. 1. You can use different types of UDFs, such as scalar, async, and generator. For example, if you're calling a REST API, then use an async UDF. If you see multiple objects that you want to process individually, then use a generator UDF. So in this case, we'll be using a generator UDF. And 2, you can tune your UDF by configuring the batch size. By doing so, you reduce the amount of rows processed at a time. This helps reduce memory utilization and also enables Daft to execute the UDF more concurrently. Now that we've implemented these 3 tips and optimized our workflow, let's try running the script again and see how long it takes. I'm going to skip to the end when it's done. Our script is done, and it took 24 seconds to complete. Not only did we decrease the time from our initial version, we also have more insights into each step of the process, making it easier to make further optimizations and improvements. So in summary, break down your UDFs into smaller chunks, use Daft's native expressions, and tune your UDF. Check out our documentation for more information on using custom code in Daft, and pip install Daft today to get started. Thanks for watching.